Yesterday we talked about box and whisker plots and those measures of center. Today we want to talk about standard deviation and variance. Now, measure of variation is going to be that value that describes the spread of the data set. And we'll talk more about this bell curve tomorrow with normal distribution. But basically it's just showing a value that describes how the data is spread out. And then the big thing we're looking at today is standard deviation and variance. And standard deviation is denoted by sigma, and it's the square root of the variance, and it's one of the most common and useful measures of variation. It basically tells you the spread of the data from the mean and how it should all fall. Now, a low standard deviation indicates the data is clustered near the measures of center or near the mean, which means that you're going to have very little variation from that mean. Now, variance, as you can see here, is denoted by sigma squared. It's the average of the squared differences from the mean, and we're going to talk about exactly what that means. So, on the other hand, from what we were talking about a second ago, if you have a high standard deviation, it indicates that the data is clustered far from the measures of center, or it's very spread out. So first thing we're going to do is take a look at some examples of calculating variance and standard deviation. So we have this graph of numbers of panthers. And so the first thing we want to do is take a look and put our data into our table, or sorry, these are heights. So we have a 69. Each dot represents a point. We have a 73. We've got 1, 2, 3, 4, 5, 6 74s. And we got a 75 and a 79. And so then the thing we're going to do is we're going to find the mean of this data set. And so if we take these numbers, we got 69 plus 73 plus, I'm going to do 74 times 6 plus 75 plus 79. We get a total of 74, and we're going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide that by 10, and we get 74 for our mean. So we're going to write down that our mean, as x with a bar over the top, is 74, which is pretty consistent since most of the numbers are 74. The second piece we're going to do is to find the difference between the mean and each data value and then square it. So that means we're going to take 74 minus 69, which is 5, and then so we're going to write that down here, which is 5, and then we're going to square it to get 25. So then 74 minus 73, I'm sorry, take that to be negative 5, but then it's going to be squared. So 73 minus 74 is negative 1, square it, you get 1. And then we have zeros across here. And then we take 75 minus 74, we get 1, and we square that to get 1. And then 79 minus 74, which is 5, and that gives me 25. So now, the third step is going to be to find that variance. And our variance, as you can see, is our sigma squared right here. And we're going to do that by adding up all of the squares of the differences. So we're going to add up all of these values and divide by how many there are. The nice part is with having 6 zeros, we really just have to add up 25, 25, 1, and 1, which is going to be 52. And if we take 52 and divide it by our 10, we're going to get a variance of 5.2. And so that is our variance, or how much our data varies. Now step 4 is going to be to square root the variance to get the standard deviation. So if we come over here and we square root our answer of 5.2, we get a standard deviation, or sigma, which is equal to 2.3. And so basically what this means, because that's a pretty low standard deviation and relatively low variance, is that with the, as you can see by the table, with the exception of the 69 and the 79, our data values are very closely linked to each other. Our next step is then going to be to use, how do we look at using a graphing calculator to get this information? And I'm saying more so than just using it to do the number crunching. So the first thing we want to do is look up at the top at our stat button, or our button right here. It's our stat button right here. And as you can see, there's a bunch of lists. We want the edit. So as you can see, because it's already highlighted, we're going to hit enter. And we get this L1, L2, L3. So what we're going to do with that is we're under L1, we're going to enter our data set by pressing enter after each value. So as I bring this up, I'm going to go up a little bit so I can get all my data points. So over here, I'm going to enter 92.8, enter, 92.9, enter, and 92.7, enter, 92.7, enter. I got two 90.7s, and I'm going to 92.9, enter, 92.8, enter, 92.9, enter, 92.9, enter, 92.8, enter. Make sure I've got my 1, 2, 3, 4, 5. And then 92.7, enter, 92.9, enter, 92.8, enter, 92.1, enter, 92.9, enter, and 92.8, enter. And so we've got all of our data points in there. The next step is going to be to go back to the stat button, go over to calc, and then one variable stats and enter. So we go stat button, we're going to area over to the calc button. One with one variable stats is what's highlighted, so we'll hit enter. What you will hit enter twice, actually, instead of just once. And as you can see, you've got all these numbers. So our step forth is, we'll have all these numbers and we can arrow down to get more data. But as you can see, the first bar, or first one, X with the bar over the top, which is our mean, that's going to be approximately 92.8. And then we see here we've got our sigma X, which our sigma X is, remember, which is the fifth one down. So if I arrow here, I can see the sigma X is 0.1948. So our standard deviation is going to be 0.195, which means that our data is very close together. And if we actually square that, you can see that we have a very small value of variance. Now if you notice, the variation, or that sigma squared, I realize there's a capital sigma squared, but we're talking lowercase sigma squared, is not listed. And so what we actually have to do for the variance is, yeah, we could go through and calculate all this right here. Instead, I'm knowing that my standard deviation is approximately 0.195 and that our variation is that squared. I'm going to exit out of this, and I'm going to take that 0.195 and I'm going to simply square it, and we get 0.038. And I know we normally don't go that many decimal places out, but because it's so small, we want to make sure that we do that. And so what I need you to do right now is, I'm giving you, for the U-try problem, a data set that I want you to use that data set. What I really would like to see you do is to calculate these values by hand and then go back and instead use the calculator, if you have a graphing calculator access, to check it. I've also been told that there is a graphing calculator app that you can get that is free, so please check that out. We'll look into it and we'll check that out for class for tomorrow. Please make sure you do this and then bring your questions with you to class tomorrow.